So I'm going to do section 4.1 on angular measure. Now, this section is kind of disjointed in that each example seems to talk about something different, but we'll go through them one by one. So the first thing that they talk about is something called radians. Usually when we have a circle and we talk about the measure of the circle, we talk about it in terms of angles, and we measure the angle in terms of degrees. Even if we have a triangle, if we wanted to know what that angle was, we would talk about it in terms of degrees. Is it 36 degrees maybe? Is it whatever? But it's in degrees. Well, just like if I said I want you to measure a table, you could measure that table in centimeters, you could measure that table in meters, you could measure that table in inches. There are different units you can measure it in. When we talk about something like an angle, you can measure something in degrees, which is what we have done up to this point. You can do it in something called gradians. Now, gradients are used in engineering, and so we don't actually touch those. We don't look at the gradient measuring system. But the one we do look at is this one over here called radians. We use radians when we're doing higher level math like calculus and things like that, which is why they introduce it now. Because if you're going to go on and do calculus, they're going to do a lot of things in radians. So just like if I said you have something that is 6 centimeters long, and I want to know how many inches is that, if I wanted you to convert from one form to another, you would have to know the conversion factor. And the conversion factor from centimeters to inches is there's 2.54 centimeters in 1 inch. So to convert, I would put 1 inch on top and I would put 2.54 centimeters on the bottom. The reason why I would put the centimeters on the bottom is because then those centimeter units cancel and all I have left is inches. So in my calculator, I would do 6 times 1 divided by 2.54, and I would get my answer in inches. This is exactly the same idea. So when we're talking about radians, we often talk about it in terms of pi. So pi is that thing that we're familiar with, that 3.14. But in radians, pi is the same as 180 in degrees. So if I asked you what is 180 degrees in radians, you would say it is pi radians. Very often we leave radians in terms of pi. There will be a pi in the answer. So we're going to look at example number 1 on page 187. And what example number 1 talks about is if you have something in degrees, how do I convert it into radians? So if you have 45 degrees and you want to convert it into radians, the conversion factor is there are pi radians in 180 degrees. That's going to be your conversion factor. Now, the reason why I put the 180 degrees on the bottom is so that the degree units will cancel and I will just have radians. Now, how I leave it is I have 45 pi over 180. The only thing you do with this is to reduce this fraction. If you go to your calculator and you put 45 over 180, it tells you it's 1 over 4. So it's 1 pi over 4. And so 45 degrees in radians is pi over 4. And so same thing if we have 210 degrees and we want that in radians. We know that there are pi radians in 180 degrees. Your degrees will cancel and you have 210 pi over 180. Now what I do is I take that 210 over 180 and I reduce it. It turns into 7 over 6, but that pi is still there. So it's 7 pi over 6 radians. Even if you have a negative degree, so even if you have negative 120 degrees, it's the same thing. There are pi radians in 180 degrees. So my degrees cancel and I have negative 120 pi over 180. But if I reduce 120 over 180, I end up with negative 2 pi over 3 radians. And we just leave it like that. Now, could you go and multiply 2 times pi, so 3.14, but you have a pi button on your calculator? Could I do 2 times pi divided by 3 and get an answer? Yes, but you'd end up rounding it off, so we don't do that very often. So in example 2, they want you to convert the other way. So instead, they give you 4 pi over 3 radians, and they want you to convert that into degrees. So it's 180 degrees over pi radians, so that your radians cancel, and by the way, so do your pi's. You have a pi on top and a pi on the bottom, they cancel. So you really just do 4 times 180 divided by 3. And 4 times 180 divided by 3 is 240 degrees. So again, if you have negative 3 pi over 4, you would multiply it by 180 over pi. Your pi's would cancel. And you really just end up doing negative 3 times 180 divided by 4, which is negative 135. Now, one of the things I remember is that pi is 180 degrees. So really, I just can do negative 3 times 180 divided by 4. It gives you negative 135. You can just think of that pi as a 180 and do negative 3 times 180 divided by 4, and it'll give you the same answer. The only difference is sometimes, very rarely, but sometimes they will give you something in radians, but they won't give it in terms of pi. For example, they will give you 2.5 radians. There's no pi in that because what they've done is they've multiplied the pi in. So we're going to multiply by 180 degrees over pi radians so that the radians cancel. So in your calculator, you're going to put 2.5 times 180 and you're going to hit divided by pi. You're going to use your pi button. So you're going to do 2.5 times 180 divided by pi, and it's going to give you 143 point, and it gives you a big long thing. They round it off to the nearest hundredth and say 143.24 degrees. That is the only time when you actually use the pi button in your calculation, is when they don't give it to you in terms of pi. So negative 0.4 radians would be times 180 over pi radians. So cancel out your radians, do negative 0.4 times 180 divided by pi gives you negative 22.92 degrees. So that's just really talking about switching from one form to another, either from radians to degrees or degrees to radians. Okay. So I said this was disjointed. That was really example 1 and example 2. The other thing they talk about is a place where they use things in radians. And that's with this idea of you have a circle, okay? And you have a piece of it that you're looking at. They call this piece in here, they call it a sector, okay? So it's just the area, the piece of the pie, I guess, that you're looking at. Now, your radius is here, right? Because it's the length from the center to the edge. This angle right here inside that sector is called your sector angle. So this is called your sector angle. Now, the distance along the edge of the circle, that curved edge right here, let me see if I can do that in a different color. Okay, so this curved edge right here, from one edge of the sector to the other, that is called your arc length. Arc because it's curved, and length because that's the length. So, if you are given some information, there is a formula for figuring out any piece that's missing. And it's really just comparing two things. So arc length over 2 pi r. The reason why 2 pi r is because 2 pi r is the circumference of the circle. So you are comparing the arc length, the length of that piece of the edge, with the circumference, the distance all the way around the edge. It's a ratio, it's a comparison. Now that's going to be equal to your sector angle divided by 2 pi. Again, the reason why 2 pi, remember pi is 180 degrees. So 2 times 180 would be 360 degrees. 360 degrees is all the way around the circle. So you're comparing just this piece of the angle to the whole circle. So again, it's just a ratio. The sector angle has to be in radians because you've got pi's everywhere, and radians is the only measure that has pi in it. So if we look, I am on page 188 in your textbook. If we look at example 3, in example 3, they give you a circle. In example 3, they give you a circle, or an oval apparently when I draw it. They give you a circle, and they tell you that this right here is 10. That would be the radius. And they tell you that the sector angle is 1.7. It's not 1.7 degrees, it's 1.7. That means it's in radians. And they want to know, what is this out here? What is your arc length? So I'm going to fill in what I know down here in this formula. Arc length is x over 2 times pi times r, which is my radius, which is 10, is equal to my sector angle, which is 1.7 over 2 pi. So for me, I would do 2 times 10 is 20. So I'm going to go up here. So I would have x over 20 pi equals 1.7 over 2 pi. Now, I cross multiply, but some people don't like that. So let's say you want to get rid of this denominator. So you multiply this side by 2 pi so that your 2 pi's cancel, and you just have 1.7. If you multiply this side by 2 pi, your pi's cancel, and you have 2 over 20, which is 1 over 10. So I have, so I have x over 10 equals 1.7. So I'm going to multiply this side by 10, so my 10's cancel, and I have x. So I multiply this side by 10, and I have 17. So my arc length is 17. So another one of those, and you can use your calculator for that, that's no biggie. Another one of those, they give you a circle and they tell you that this is 4, this is 6, and this time they want to know what this is. Now they put a theta there, I'm just going to put an x. So arc length, well that's 6, over 2 times pi times r, my r is 4, is equal to my sector angle, which I want to know, over 2 pi. So for me, I would do this is 6 over 8 pi equals x over 2 pi. So again, up to you how you want to solve this, but I'd multiply this side by 2 pi so that my 2 pi's cancel and I just have x. So I'd multiply this side by 2 pi. So my pi's will cancel, and I have 2 times 6 is 12, and 12 over 8 is 1.5. So my x is 1.5 radians. All right, that's example number 3 out of your textbook for section 4.1. Okay, so now they kind of jump topics again. I said they jump around in this one a lot. And they are going to talk about some terms, okay? So when we have a Cartesian plane, and you took physics, so you know a little bit about this. When we have a Cartesian plane, we have our x-axis, we have our y-axis, but we can talk about this in terms of degrees. This would be 0 degrees. This would be 90 degrees. This would be 180 degrees. This would be 270 degrees. And this would be back to 360, right? So you've got your full circle. Now, if I said I want you to put a 60-degree angle into there, okay? If I said I want you to put a 60-degree angle into there, you start at 0 and you go in the you go into the counterclockwise direction 60 degrees. Now, we don't really care about being accurate. It should just be in the right section. So 60 degrees. This line that I drew here to represent where 60 degrees would be, this is called the terminal arm. It's called the terminal arm. The terminal arm is you always start at 0 and you go forward, unless they give you a negative angle. So if they said they want you to put negative 120 degrees on here, I would start at 0 and go back 90 and go back another, 30 degrees? And so this would be negative 120 degrees. That is where my terminal arm would be for that. Okay. All right. If you have an angle that is between 0 and 360, it is considered a principal angle. So an angle between 0 to 360 degrees positive, that is called the principal angle. Now, there are something called coterminal arms. So I'm going to explain about that. So if I said I want you to draw an angle that is 120 degrees, 0, 90, 180, 270. So if I start at 0, there's 90, another 30 degrees. That's about 120 degrees. It's going to be here in this angle, in this section, all right? Now, if I said, I want you to draw an angle that is 480 degrees. What that means is I would start at 0, I would go all the way around, there's 360, another 90 would be 450, and another 30 would bring me here. That is 480 degrees. It's at exactly the same place as 120, except I had to go all the way around the circle once and then go that extra 120 degrees. So 480 and 120 are coterminal angles. Okay? They are coterminal arms. They're drawn in the same place. And even if I said, I want you to draw me an angle that is negative 240 degrees. That would mean I would start at 0. I would go back 90, back 180, back another 60. That is negative 240 degrees, but it again, I don't know why I drew it from back there, it again is a coterminal arm. Okay? So they're all in the same place. And by the way, when I was drawing that, I should have been drawing my terminal arms from the origin. So I should have been drawing them all. I should have been drawing them all from 0 and 0 out. I screwed that up. I'm sorry. All right. So in example number 4, they want you to figure out one positive and one negative coterminal angle to something. It's actually really easy to do. It sounds complicated. So they give you 210 degrees and they want one positive and one negative coterminal angle. So all you have to do, remember we went around the circle an extra time. So if I just add 360 to 210, I get 570 degrees. That is a positive, because it's positive, coterminal angle. They would be drawn one on top of one another if I was to draw them. If you want a negative coterminal angle, just subtract 360 degrees. That's going to be negative 1, what is that going to be? Negative 150, I think. Negative 150 degrees. I'm not sure. Just a second. Let me see if I did it right. Yep, negative 150. I did it right in my head. That's good. So that is a negative coterminal arm because it's negative. You can do the same thing with it in radians. It's just, I don't think as well in radians, so I have to think a little harder. But they give you 2 pi over 3. You want to have that up, you want a positive coterminal angle. Well, what I did when it was in degrees was I added 360 degrees. 360 degrees in radians is 2 pi. Remember, pi is 180, so 2 times 180 would be 360. So I would just add 2 pi. So if you do that, that works out to be 8 pi over 3. And you can just add 2 over 3 plus 2 to give you 8 over 3 and stick the pi in. If you want a negative coterminal arm, you subtract 2 pi. And so if you, and again, I would just do 2 over 3 minus 2, but it ends up being negative 4 pi over 3 is what it ends up being. So there's a negative coterminal angle. So when they ask you about coterminal angles, just add 360 and subtract 360. If it's in radians, add 2 pi, subtract 2 pi. So the last thing that they do, I think I'm going to skip because I don't think, Like, I'm not going to ask you one like that probably on a test. So we're going to end this section here, and you can look at what the homework was for this section. Hopefully this helps. So we'll hopefully see you soon.